Hello. Now we are going to discuss about our lecture number 16, which will tells us that about the synthesis, processing and characterization of the nanostructured coatings. So, here in this particular chapter we will mainly discuss about that there are several types of synthesis methods, different types of processing techniques and how to characterize or maybe how to measure that whether this coatings is proper or not, and maybe the what are the relations in between them or not. So, in our previous lectures we have actually discussed about different types of coating methods, and now we are going to discuss that how we are going to use those methods for this particular structure. So, first we have to know that why nanostructures are important, why nowadays we are talking about the nanostructures every time, nanomaterials, nanocomposites, why the term nano is coming each and everywhere. Because as we know that when we are talking about the bulk properties or maybe that when we are talking about the micro properties, maybe there is having some kind of saturations of these techniques by which we can enhance the material properties up to certain limit. And not only that, if we want to increase those properties, maybe for one or two applications we are achieving these results, but if we want a variety of applications for that particular materials, then maybe that bulk properties or maybe that micro composites are not working properly. Then we are talking about the nano composites or maybe the nanostructures by which we can change the material properties up to a big variety, that means the application will be more. So, first is called the nanostructures have a volume that is intermediate between the molecular and the microscopic dimensions in micrometer structure. So, it is ranging from a small tiny particles which we can't see by our naked eyes to the macroscopic or maybe the microscopic levels. So, it is in between that, maybe from nanometer range to the micrometer range. As an interesting examples of nanostructures, different nanostructures of carbon such as fullerenes, nanotubes, nanocones and graphene have exclusive mechanical and physical properties, but it is not confined in between the mechanical and physical properties, maybe optical properties, maybe electrical properties, maybe thermal properties, and there are several properties it can increase or maybe the decrease. Carbon nanostructures can also be chemically treated to achieve other activities, especially catalytic activities. Recently, some investigations have suggested that nitrogen diffused carbon nanotubes will show enough electrocatalytic activity for reduction of oxygen. So, from this example we can understand that nanocomposites is playing a vital role for enhancing several properties which we can't get by this kind of micro or maybe the macro or maybe that bulk coatings or maybe that bulk properties. These treatments also become very attractive by forming stable metal diffused carbon nanostructures for applications with catalytic activities. Considering these attractive potential uses of nanostructures, interest in their applications is growing increasingly. So, these all are the different properties by which we are using this kind of nanostructures, but here the properties are very few. There are n number of properties by which we can prove that nanostructure is the more suitable or maybe that more having more future requirement for our coating techniques. So, what is so interesting about nanostructures that the global researchers attention in recent years. So, here we are giving one examples, one literature survey just to showing you that why we are going for the nanostructures, what is the demand for it, why we are going for this kind of techniques or maybe why we are adapting this kind of techniques and what are the logic behind it. It can be summarized as the term called is the size effect. So, consider a piece of semiconductor and its band gap, important electronic properties. So, here we are trying to make you understand in terms of some kind of electronic properties that where we are going for the nanostructure. So, from the term nano is nothing but the 10 to the power minus 9 meter. So, you can see that how much tiny size it is which we can't see by our naked eyes. For seeing this kind of particles, either we need some kind of microscope, either it may be the scanning electron microscope or maybe the transmission electron microscope. Next, decreasing its dimension to small pieces about 100 nanometer Average length will not influence the band gap, but further decreasing its dimensions to smaller pieces with average dimension less than 10 nanometer will change its band gap and cause it to show some new properties such as visible light or enough catalytic activities for specific reactions. So, from this particular sentence you can understand that when we are decreasing the size of the band gap, size of the particles from 100 nanometer to 10 nanometer, some of the hidden properties of this particular material is coming out, like that it is showing some kind of visible light or maybe some kind of enough catalytic activity when the material size is around 10 nanometer. The varying properties of materials on nanometric scale have been investigated through research in recent years and have created many industrial applications of the nanostructure itself. Next, till now we are talking about the nanomaterials, that why we are going to use this kind of nanostructures, but in this particular PPT or maybe the slide we are going to discuss that why we are going for this kind of nanostructured coatings, why we are not going for the bulk coatings or maybe that some micro or macro structure coatings. So, surface coatings are an important industrial activity with a wide range of applications. So, as we already know that when we are going to do this kind of coatings, just we are changing the outer surface of that particular materials, we are not hampering the materials itself or maybe we are not changing the materials inherent property, simple the outer surface of that material properties we are going to change so that it can shows the different properties into different manners. These are several types of surface coating technologies, for instance paints and varnishes, electrolytic depositions and the projections. One important characteristics of nanomaterials is their high specific surface from some meter square per gram to several hundred of meters cube per gram. So, you can change the wide variety of materials for these particular properties. Therefore, their capacity of interactions physical or chemical is highly significant even for low concentrations. Their interest is then drastically increased in case of modification of performance of coatings without any perturbations of the manufacturing procedures. That means, we are not going to change the material properties, we are not going to change the material structure or maybe the material chemical structure, rather simply from the outer surface only the physical properties of that materials we are going to change by this kind of techniques. So, synthesis process, there are several types of synthesis process, we have discussed some of them in our previous lectures. First one is called the general methods, which is known as the solid state synthesis techniques, generally milling operations, mechanochemical milling. There are several types of difficulties or remarks are available. First one is called the difficult to obtain monodispersed distributions, room temperature compatible. So, these all are the different problems. Actually, we know that if there is no ending of any technology, there will not be any new technology will be developed. So, unless and until there will not be any problem for this technology, we will not go for the nanostructure or maybe the nanostructure properties of that particular material. So, here when we are talking about the vapor phase, we are talking about the PVD physical vapor depositions, CVD chemical vapor depositions, flame pyrolysis, plasma. So, in this particular case, for suppose for PVD we are having some limitations to thin layers. When we are talking about the CVD, investment cost is generally high, equipment cost is more high, and when you are talking about the flame pyrolysis, specific gravity of particles generally low. When you are talking about the plasma, high equipment cost and limited productivity. When you are talking about the materials in the liquid formations, we are having that sol gel technology, we are having the colloidal chemistry, we are having the hydrothermal chemistry. So, in this particular case we are having some possible difficulties such as repeatability, reagglomerations also pose some problems, high temperature and pressures. So, these all are the different limitations, different problems. So, that is why we are going for the newer technology or maybe the newer coating methods, which is known as the nanostructured coatings. So, from the left hand side figure you can see that we are having some kind of nanostructured materials. So, which is having the 50 nanometer size, then we are having that intermediate size, we are having the around 59 nanometer, then we are having some kind of microstructure. So, here from this example we can see that example of nanostructure coating developed by TNO in the Ambio project. The effectiveness against biofouling is determined by the size and distribution of the surface structure. So, from this particular case you can see that nanostructure is into the horizontal positions when we are just putting into the longitudinal directions, then that properties is giving the better results. So from this AFM figure we can see that different types of structures is found, we are getting onto the substrate itself. Here is also some kind of schematic illustrations for 4 microstructures of nanocomposite coating with enhanced hardness. First one is called the nanosize bilayers. So here you can see on the substrate we are giving the different types of layers of coatings onto the materials itself. Next one is called the columnar nanostructure, in which the nanoparticles is stacking into the longitudinal directions. Then nanograins surrounded by a tissue phase, here the nanoparticles is simply dispersed onto the substrate itself. And last one is the mixture of nanograins with different crystallographic orientations. Some nanoparticles may be into the horizontal position, some nanoparticles into the into the longitudinal position. So it is a mixing of different nanoparticles onto the substrate itself. Next, processing and characterization of the nanostructured coatings, that is the main motto of this particular lecture. So how we are doing, how we are preparing this kind of nanostructures, how we are making this kind of nanostructured coatings onto the substrate itself, what are the methods and what are the advantages and disadvantages of this kind of methods. So first, the characterization is done to confirm the fact that particles are rarely isolated. Indeed, synthesis of process lead to elementary particles which tend naturally to agglomerate and then to agglomerate. The biggest problem of these nanostructures or nanoparticles is that when we are trying to mix it into some solutions, when we are trying to mix it into some matrix or maybe the blends or maybe the alloys, due to its small size and high surface energy, it is tried to agglomerate. That means the nanoparticles should not or maybe unable to distribute all among the blends or maybe that substrate, just it is trying to do the make a separations and it is trying to make a agglomerations and or maybe the heap of the nanoparticles into a one side or into inside the matrix. So the nanoparticles distribution is not the homogeneous, it is making some kind of heterogeneous structure inside the composites or maybe that blends. The main reason for this phenomenon are particle interactions due to the surface energy of nanoparticles and the minimization of the energy for a given systems. So these all are the drawbacks for these particular techniques. Some key characterization techniques required to study nanostructured coatings are morphological, mainly electron microscopy, that means morphological study of this kind of nanoparticles, dimensional like grain size distribution and the specific surface geometry, and then the functional like electron conduction, sensitivity to the magnetic field, color, luminous emissions, absorption, sensitivity to temperature, etc. That means those all are the physical properties of this particular techniques. So from this particular figure we are giving some kind of elementary particle having one size, then aggregations is taking place, then agglomerations is taking place. That means stacking of the nanoparticles in a particular phase and they are making a heap of the nanoparticles and not mixing properly inside our composites, blends or maybe the alloys. What are the applications? These are many applications of nanomaterials and it is not relevant there to study them exhaustively. Only the applications at a pre-industrial stage will be discussed here, because there are n number of applications. If we start this kind of applications, maybe it can take an hour or maybe more than an hour. So just here we are keeping our applications for the pre-industrial stage or maybe in our laboratory studies or maybe our research based studies. First one is called the hard coating and the tribological functions. So just doing this kind of techniques sorry, we can do a hard coating and the tribological functionalities of these particular techniques. First one is called the coatings with chromium oxides. So simple, here we are doing some kind of thermal projections, thermal spray projections of our nanoparticles. So we are having the anode and cathode, simply we are applying the gas and then it is making the gas is atomizing into the plus ion and minus ion, then it is atomizing and a high velocity of plasma is forming. In this particular plasma we are putting the powder, that means the particle which we are going to coat onto our substrate, simply we are mixing, then through this temperature this powder particle is getting melted and then simply it is depositing onto our substrate itself, then it is making a layer form onto the substrate itself like a thin film or some kind of things. So, protecting metallic parts against corrosions, erosions and chemical aggregations is often realized through ceramic coatings. They present a huge chemical inertia and an intrinsic hardness. So, just applying the chromium oxide onto the substrate itself, we can enhance this kind of properties onto our substrate. Advanced thermal spray makes it possible to inject directly into the plasma a suspension of nanoparticles. This technique was operated to deposit a nanostructure layer of chromium oxide. So, here just we have given a example of the chromium oxide. We can put like this, like titanium oxide, aluminum oxide. So, there are several types of hard materials which simply we can use and we can put onto the substrate itself. So, here just it is an example that when we are talking about the wear behavior of chromium coating. So, first for the commercial material type 1. So, first for the commercial material type 1. So, we can see that the wear rate is around 0.6 millimeter cube per Newton per meter, but when we are talking about the commercial material type 2, so it is increasing up to 1, but when we are doing this kind of nano coatings of our material surface, then the wear behavior is around less than 0.1 millimeter cube per Newton per meter. So, this is the things that when we are doing this kind of coatings, the wear behavior of that particular material is totally decreasing and it is coming to almost 0. So, abrasion resistance of different chromium oxide coatings, the two first materials are microconic and the third one is less than the 20 nanometer. So, from first two cases we have used the nanoparticles having the micrometer range. Now, in the third case we are using this chromium particle into the nano size range. So, that is why it is drastically changing the material properties. Next one is called the structural reinforcement of polymers. The structural reinforcement is based on a significant contribution of a material with improved performance. So, that means efficacy of the structural reinforcement versus the concentration and the type of additives generally we are applying. So, here we can see that we are applying different kind of nanofiller concentrations, that means the loading of these nanofillers for a particular system. So, whether we are going for a 1 weight%, 2 weight%, 3 weight% or different types of loading of the nanoparticles, here it has been given like 0, 0.2, 0.4, 0.6, 0.81, and then here this side we are getting the modulus of different particles. So, when we are going for a small particle size, then that small particle size and small concentrations is equally distributed into the matrix composites, which is giving you the better properties, but when you are increasing the concentrations of those nanoparticles, then automatically the properties is going down. That means that nanoparticles is making a agglomerations into the matrix, inside the matrix or maybe the inside the composites, which is reducing the material properties drastically. Here also the friction force. So, here the example is that reduction of the friction force through coating on security straps NM1 and NM2 are compositions loaded with nano materials. So, here some kind of untreated materials, some melamine, GTV05, GTV04. So, these all are the some kind of, you can say that, obtained results from the literature review, just to show you that if we change the particle size, how the material properties is changing. If we change the concentrations of those nanoparticle inside the composites, how the material properties is changing. So, structural improvements are huge and there are many applications of these materials in automotive and aeronautics. For instances, the use of spherical nanoparticles allows the building surface with controlled nano roughness. Next one is called the biocides. So, from the name itself we can understand that these materials can be used for the biomedical applications or maybe that for the biology purpose. So, biocide compounds are widely organic materials. One important drawback of the family of materials is their allergenic effect and the capacity of bacteria to develop specific resistance to them. Feature of biocides: these nanoparticles with a diameter of several nanometers have an important efficacy, but they present some risk not well identified today of skin penetrations. So, here this material we are using for the skin material applications, or maybe that for biomedical applications. In addition, building a biocide coating is supposed to qualify its efficacy against different agents like bacteria, virus, fungi, etc. The qualifications is easy at the laboratory level, however, it is supposed to take a portions of the substrate, destroying their integrity of the product. So, simple this kind of material simply we are using for the biomedical applications. Here one example just we are trying to show you that Epidoris SAS realized a silver based ceramic composite built of a ceramic core on which silver nanoparticles were engrafted. So, here the outside material we are putting some kind of silver nanoparticles ranging from 5 to 15 nanometer, and the inside material is submicrochromic, some kind of ceramic core is around 0.5 to 1 micrometer. So, here it is a structure of silver ceramic composites in where inside is the ceramic materials and outside we are putting the silver materials. So, introduction of this kind of materials is an organic base leads to a coating of an excellent efficacy, particularly due to their morphology. So, these all are the added advantage for this kind of biocides mechanisms. Here also one kind of examples we are showing that in which we are taking the substrate as maybe some polymer, metal, textiles, etc. Then we are incorporating some kind of silver nanoparticles having 15 nanometer diameter loaded in an organic layer, polymer layer like polyurethane acrylic having 0.2 to 0.5 millimeter thickness. So, simple here we are putting a polymer nanocomposites coating onto our substrate itself, and in this particular case just we are changing some kind of silver oxide composites made of silver nanoparticles having diameter from 10 to 15 nanometer engrafted on a ceramic coat type. This is some ceramic materials in which it is surrounded by some kind of silver nanoparticles, and then the whole this silicon with silver nanoparticle is encapsulated into the polymer layer, and then this is a coating onto the material itself or maybe the polymer itself. So, the potential of applications of such material is wide at home, working table, kitchen and bathroom furniture, in hotels and restaurants, and more generally in the medical areas. So, as I told already, this kind of materials is widely used for the biomedical applications. In addition, nothing was said about the ceramic matrix. It can have its own functionality, and then this composite becomes a multifunctional material. So, these materials is showing different applications for different materials. Then we are doing the coatings for the fire retardancy. So, simply we can increase or decrease the fire retardant properties of that particular substrate or maybe that particular material by doing this kind of coatings. So, fire protection is widely required for many applications. Fire retardant compounds bring often environmental risks as antimonial fluorides for instance. In these specific applications, some fire retardant compounds are based on phosphates and require for a relevant efficacy several successive coating operations, though high volume baths. Next, here how we are going to do it? Methods of enabling reduction of flame propagations, exhausting water vapor, then automatically it will increase the flame retardant properties, separate combustive agents, oxygen consumptions, exhausting carbon dioxide. So, these all are the techniques by which we can increase or decrease the fire retardancy for this particular material. Where is the examples? Synergistic effects. So, this one is the literature study which we have done in our lab itself. So, in this particular case what we have taken? We have taken some kind of carbon nanotubes, then we have done the modification of this kind of nanotubes by two different methods. One is called the isothermal hydrolyzations, one is called the chemical precipitation method. So, by these two methods we have seen that isothermal hydrolyzation is giving you the better properties because we can control the thickness of zirconia, because here we have done the zirconia coating on carbon nanotubes. Then we have done for different materials like multi-wall carbon nanotubes, for single wall carbon nanotubes. Then we have seen that isothermal hydrolyzation process by which the layer of the zirconia onto the carbon nanotubes can be increased or decreased. That means it is a controllable approach, but while we are talking for the chemical precipitation methods, we have seen that zirconia is totally agglomerated onto the surface, thus it is not giving you the better properties. So, here then this kind of modified carbon nanotubes we have mixed into the PVDF solutions. So, into the PVDF solutions we have made the composites and then we have tested the fire retardant properties. So, in this particular case we have seen that first initially we are having the PVDF with the pristine MWCNT, then PVDF with MWCNT with zirconia composite prepared by isothermal hydrolyzation process, which I have already mentioned, and the lower one is called the PVDF based on MWCNT zirconia oxide nanocomposites by the chemical precipitation methods. Here we have shown one kind of schematic diagram by which we have shown that how the mechanism is going on onto the MWCNT by coating this kind of materials. And right hand side we have shown the heat release rate. So, initially when we are talking about the A is nothing but the pristine PVDF. So, when we are heating that material, it is having a high heat release rate around 700 degree, and then within 400 seconds the total material is finished. But when we are applying this kind of coating materials inside the matrix, we have seen that almost for the D samples, then when we are going for the C samples, it is giving you the maximum time that material can sustain, and also the heat release rate for this particular material is very low. So, just the important parameters what we are showing to here, that when we are using some kind of coating techniques onto the materials, some kind of nano coatings onto the materials of that CNT, the automatically the material heat release rate is decreasing, and not only that, the sustained temperature of that particular material is increasing. So, here now we are coming to the summary, that in this particular lecture we have learned that why nanostructures are important and how size factor affects the properties. So, when you are talking about the macro properties, macro size, then the material is showing some other properties, but when we are same material we are applying into the nanoscale size, the material properties is totally changing. Different processes are used for synthesis of nanostructure are milling, physical vapor depositions, chemical vapor depositions, flame pyrolysis, etc. Due to size effects, nanostructure have gained the high importance. The applications of nanostructure coatings are very wide, but here we have covered some interesting ones related to field of architecture, biocides, fire, retardancy in brief. But here we have shown a very few parameters, but by using this kind of nanocomposite coatings we can change the several material properties of our substrate, or maybe as per our requirement. Thank you.